Live from planet Earth. It's December 11th, whatever year it is, 2022. This is the developers meeting for the Sky 360 UAP tracking project. And take it, Richard.
Thank you, Santa. So I switch back to the overview. So welcome everyone. I hope you're all in Christmas mood right now. If not, take the time and get your eggnogs or whiskeys, or what do Texans drink today at that time? Coffee.
Okay.
Iced tea.
Tea. Oh. Hey,
Plenty of
Hi,
good old vodka.
Iced tea, that's what we drink.
Are you Israeli? You do not count for the US.
I am actually American. Thank you.
Oh, I thought you were Israeli. Sorry. Really, you're an American. Okay.
Yeah, I'm citizen in America. I'm also citizen of Israel, but I'm...
Yeah, but you were
American
born
now.
in Israel, weren't you?
Yeah.
Yeah, okay. At least I'm the right there, right? You're born
Yeah.
in Israel. Okay, got it. So for me, you're, let's say, half in Israel, right?
In Texas, we have an expression. I wasn't born in Texas, but I got here as fast as I could.
Exactly. Yeah.
All right, everyone. So, yeah, first of all, Joe is here for a second time. No, even you already had 2 times before. Just introduce Joe to the rest. Joe is doing hardware and especially mechanical hardware and design. So he goes, I think, for the pan-tilt focus rig, right?
Yep.
Perfect. And can you just give us your first ideas that you had with this idea?
Yeah, want me to start sharing my screen and go over it quick?
All right.
Okay. Let's see. Okay. It's my first time doing this, so hang with me. Okay. Whoa. Okay, can you guys see me moving it around?
Yeah.
Yeah.
Okay. So, real quick, my background, I work in the metal manufacturing. So I do a lot of sheet metal and machining and welding and that kind of stuff. So I wanted to come in here and try to make the rig cheaper and see what I can do to help improve it. So I got did a little work. What I did is I imported it all into SolidWorks and then adjusted it and then brought it back in, just because there's no smart features in how you guys have it set up. So I think at the end, like once we get all set it up, we can change whatever we want. But right now I'm just trying to get some ideas down. So there's bolts that aren't really lining up right now, but I'm just trying to get the ideas out. So I have the original rig in here still somewhere. So this is the original one. We have these machine parts, and I try to get all the machining out that I could because machining is very expensive. So anything we can do on the laser, that's what I want to do.
Yeah.
Personally. So hide the original one. So basically I got this one and I turned it into a sheet metal piece. So I don't know, I'm assuming you guys were probably using 6061 aluminum or something like that.
Yeah.
You'll have to change the material to 5052. I don't know what you guys call it overseas, but it's a formable aluminum.
Yeah, okay.
And then instead of tapping the aluminum, so what I did is put these PEMs in, PEM. They're press fit nuts, and so these are steel, so you don't have to have aluminum threads, and it's a lot faster to press those in than to machine them.
Okay.
So I got those in there.
Do you need a machine to press it in?
You need a press, but it doesn't take like a whole bunch of force, like you don't need a huge hydraulic press or anything. This PEM makes special presses, but I don't think you need something big like that. An arbor press might even work, but I think you might need a little bit more than an arbor press can do.
I'm just thinking about, because it's in a narrow U shape, how to press it.
Yeah, so you could, I think, since these are so short, you could probably press them in before you bend the sheet metal. Because
yes,
yeah,
Yeah, true. Makes
So I
sense.
don't think it'll get in the way of the punch.
Okay, got it.
We can always move this up too and get it out of the way a little bit more
Okay.
if we need to.
Perfect.
Let's see.
One
So
question.
that gets rid of the.
Can you
Go ahead.
move it? Can you pan it downwards that we see more of the upper one?
This one?
Other way around.
Oh, up.
Yeah, up. Yeah.
Okay. So I forgot to I did. Oops. I did make a new cradle. I just forgot to upload it. So I kind of did the same thing. Turned this all into one piece of a U-shaped sheet metal.
Makes sense.
And got rid of these two. And then I added another flange on this edge that went up. With plenty of clearance here, and then it'll attach to these two sides here. Probably if we can weld them, that would be great. That would increase the stiffness by quite a bit. And then we can get rid of these countersinks too, so we don't have to machine those.
Yeah, no need. Absolutely. Hey, there are two flanges to the outside, where these two on the right side, very right side, a little bit down with the mouse. Yeah, stop here, exactly there, a little bit down. So these two screws exactly these ones.
Yeah.
So there are flanges, and these flanges are resting on this rim that is twisting around. Yeah, exactly. And there's a flat.
So that can stay in there. Or we could potentially turn this into like just an L-shape bent sheet metal too, potentially.
Yeah. So you could use the horizontal plane, which is not seen yet, and bend it downwards and to fit it on the rig.
Yep. And then you wouldn't have to machine it.
Yeah. Perfect.
So, let's see, where did that ring go? So on the front side, obviously this blocks some access, but the good thing is that you can install these. You can install all your motors onto these two pieces and then put them in at the end. I don't know if you need airflow or anything for this, but this will also increase the stiffness quite a bit, especially if we can weld here. Because and the welding will be, it's 87 millimeters, just times 2. It really shouldn't take very long to weld something like that. And then, so also we've got some holes here that are really close to the edge. So I made a cutout here. That way the bend doesn't pull this hole when the metal deforms.
Okay, yeah.
If you try to bend that, it's just going to distort that hole really bad because it's so close.
Yeah, true.
So we can either move that or just do the cutout like I did.
Or you bend it and make the hole later.
Yeah, that would be machining, and that would be extra machining, and like I said, I want to avoid that at all possible.
True. Okay, true.
So, I need to make another cutout here for this guy, but kind of the same thing. Just made some PEMs here, and need to put some more holes in.
No need to cut it out. We can reuse this on the aluminum. This ring, this cylindric thing, it can be reused on the sides.
Okay. Yeah, that'd be cool. Also, so something like this bolt here, especially since there's enough clearance there, I think we should just get rid of the countersinks and just use like a regular socket head screw. Then you can avoid countersinking that again, which is more reduction of machining.
Yeah.
I think you have plenty of clearance there.
Yeah. Wow.
And let's see. The other thing I was kind of thinking about is like this bolt is going to be kind of, before the way it was, it'd be kind of hard to install this bolt because there's not a lot of room for the wrench. Maybe I'm wrong, but might have to move that a little bit. Plus, the other thing I was thinking about is the closer you move these motors to this axis, the less your rotational inertia is going to be. So maybe we can try to move that closer to the middle, if at all possible. And I will help your response on turning it. Same with this one. If we can move that closer to the middle, whatever room we have, that'd be great.
Yeah. Good point. Yeah.
Let's see.
Yeah, we can bring it closer, definitely.
Quick question.
Yep.
Yeah, quick question on those bolts that are holding those stepper motors in.
Yep.
If you put a hex head in from the inside, that would you have room for it to protrude slightly to the outside and put the nut on it that way? I think that would make it so you could, it wouldn't really matter where you put it because you get an Allen key on the wrench. Okay, it looks like that's the way you have it done. Okay.
If you put a,
I didn't see that in the last detail, but yeah. So you didn't have to machine a sink or an insert there.
Yeah.
Just thinking out loud.
No, that makes total sense because you could definitely fit a wrench, open-ended wrench over on this side.
Yeah, and like I said, you have
that might be
room
better.
to get an Allen key here, even if you
even
if you move it inward, towards the center like you were talking about. It's still if you're using an Allen key here, then it wouldn't on those, then it wouldn't really make any wouldn't be any problem holding them, and then either a nut or one of your inserts are on the outside for it.
Yeah, I like the nut idea because then you can just hold this still with the Allen key and then tighten the nut.
Yeah.
But there are 4 screws on this. How do you, if you use this sheet metal and it's already pre-bent, how do you install the other 2 screws?
So my suggestion is you have to do it. You have to put this in before you put these 2 in. When you assemble it. That way you'd have access. That's what I would do. I think you pretty much want to fully assemble these 2 plates with whatever you can before you put the plates into into this final assembly. So bolt these on, bolt this guy on, bolt this down, and then put the plates in.
Yeah, but how to fix the other 2 screws on the lower on the front motor? These.
Or this one?
No, the other one.
Oh, I see what you're saying now. I see what you're saying now. This one. Yeah.
No, this one is easy. This one is easy. But what about the interior one?
You're talking about.
Yeah, no, the other 2 opposite.
Yeah, this one. Exactly this one.
Yeah.
How about this one?
Yep.
Shall we make a
well,
hole
if this
on
isn't
the
in
other
here,
side? Before the electronics goes on, we can make a hole on the other side so that with a long screw you can pass through.
Yeah, and like I said, before you put this plate in, you can put the motor in, and then you'll have plenty of room up and down to get this in. Same thing with this one.
Okay, with the ratchet, yeah.
Yep. Yeah, so basically I just removed all these machine parts and a lot of the countersinks and a lot of stuff. So that should save quite a bit of money on the machining part.
Cool.
And yeah, so I think next step would be trying to figure out probably this guy. And
do you have the horizontal plane? Do you know where it is?
Is it one of these? That one?
No, not the plane. Not this kind of a plane. The horizontal disc that is running on the outside boundary on the ring.
Wait, this guy.
Is it on the rig?
This one?
Yeah, and in the same folder there is the metal part, and it is Open the folder, please. This one exactly, and there have been the base. Oh, it's all. Rim, at the rim, exactly. Where is it? Damn.
Is that what you want?
No. Not in origin. No. A real sheet, a sheet of metal, an aluminum part that is a ring, and it is just the center part is cut out so that the scope can rotate.
Is it?
Yeah. Anyway, I'm gonna show you. I make a screenshot with the name when I find it.
Okay.
So basically, you saved this under version 1.8 or so, right?
I did 1.7 version 9.
Version 9.
So the last one before that was version 8.
Yeah. Perfect.
So that's kind of what I got right now.
Okay.
Can you just flip back and forth between the original to the modified, or show them side by side or something?
Yeah, just a
We
second.
can visually see what really transpired there.
So this is the original,
Okay.
and then can't really. Okay, so you can kind of see the front here where I added this
Mm-hmm.
to help stiffen it.
Mm-hmm.
Yeah.
Um, so yeah, I mean, I'm not trying to change the entire design. I was trying to make it cheaper, pretty much.
Yeah.
Right.
And
Yeah, just
manufacturable.
Yep. That's my specialty. So
okay.
yeah,
So we
that's
got
about all I
away.
got.
So it looks like we got away from a lot of the bent metal and went to block, right? Just straight
Opposite
cut.
direction. Opposite direction.
Opposite.
Opposite direction. Oh, you
Yes.
added the bent metal.
Yes.
Yes.
Yeah, that's what I thought. Okay.
Yep.
So
So this is mine, the new one.
Nice facing.
And the reason I do that is because the bend takes 10 seconds to bend a thing, and then you get a entire length of the sheet metal.
Mm-hmm.
You get the whole strength of that entire piece
Mm-hmm.
compared to the 3 screws that you had before.
And
The only
this is
problem is
the thickness.
so
go ahead.
we need to talk about tooling though. Bending versus cutting is two different types of tools.
Yes.
So my point is that I thought, so is the whole design, is the whole concept here that we're now going to be in the manufacturing business, that we're now going to manufacture this product and sell it? Or is it people are going to buy the parts and put it together themselves?
Well, so here's how I'm looking at it. So before you were going to buy the rig, right? So I'm assuming you have some kind of metal manufacturer that was making these, or how are you going to?
Yeah, Richard, that's your question.
How are you going to source this, like a part like this?
Good question. So first of all, our focus was only to have a design that is of the ability to take accuracy that we are focusing on and to make it as cheap as possible. So to keep it below the 1500. This was the whole intention. The do-it-yourself was rather early dismissed because it is a high precision element that you need when you build it together. You have to have certain alignment accuracy, perfection. I don't know how to say this in English.
No, agreed.
Precision.
If someone does not do this, it can wobble at the end.
Mm-hmm.
And that
Right.
should not occur, especially if you build a scope on it. You would see every time it moves around, it would never circle. It will always have a kind of a sinus curve around, something like this. So that's why it's actually not a do-it-yourself anymore. But we can still keep this as a download for someone who wants to do it by himself because he has let's say a CNC router himself or whatever.
Right.
Yeah. So and then any metal manufacturer that's worth anything is going to have a brake press.
Oh, agreed.
So they should be able to do that.
Yeah, no problem.
The one thing I just realized though is this part is not actually formable, so I'm gonna have to change it. There's no way to basically. How do I do this? Basically, there's no way to get the tool into this one when you're doing it as the last bend.
Right.
So I might have to break that into 2 pieces because the tool has to go straight up and down this way.
Yeah.
And this is kind of in the way here. But
so it's a two-way bend. It's first you do the verticals and then you do the slanted one.
Yeah, you'd have to do these 2 first, and then do this one last.
Yeah.
And then weld it.
Mm-hmm.
Hopefully.
But yeah.
So yeah, so I did add. So I reduced a lot of machining, but you'd have to find someone that now has the capability to do the PEM with the press, and also to do the brake press bending.
Yeah, but this is
I think
a metal shop can do that.
Yeah.
Yeah.
That's what I think. And the other benefit is your threads are steel now,
Yeah.
too. We can do that stainless if you really want to. I don't know what the corrosion resistance needs to be. These are zinc plated steel, but they can be stainless also.
Yeah, we try to keep the climate inside under control.
Oh, yeah, you got a
So
bunch
that's
of
why
electronics.
we
in there.
try to keep the humidity down as much as possible. So corrosion. The only thing is, if it's in a salty environment, that might get into corrosion because it depends on the filters that we're gonna use then. But I think there are filters against salty air, right?
I do not know the answer to that.
Me not either. Okay, we have to find out.
Okay. And one last thing. There was a lot of fillets on here for your wires, I'm assuming.
Yeah.
What I would like to see is if maybe put a grommet in there or something like that.
A grommet?
Because
what is a grommet?
it's like a rubber
Rubber,
tray.
Okay, yeah, I see.
And
Rubber
that would be
grommet.
a lot cheaper because if you fill it both of those sides,
Mhm.
now you have two different machining setups.
Yeah, both sides.
And each of those are like an hour or half an hour of cost. So if we could just put a little, $1 piece of rubber in there, that would save a lot of time.
Cool. Good point.
Or plastic or whatever.
Absolutely good point. Okay.
But yeah. Any other questions?
So the cradle
Actually,
is. Sorry, Bojan, go ahead.
actually, this hole on the right side will be excluded.
You won't need it?
No.
Why not? How do you run
But
the cable?
I will come up with another solution with cables. I'm about to finish the motherboard. On the right side, you have the board, the
But how do
PC
you run
board.
the cables to the camera?
Yeah, but on another way, not like that. This is all. This is
the hole
not,
is somewhere else, but there will be a hole.
Yeah, will be hole for.
Yeah.
Of course,
Okay.
will be hole.
Got it.
But not in this place.
Yeah. Okay. Got it.
But I will post Joe. I will post on a PDF the board final version.
Okay.
Maybe even tonight, so we can figure out where we can do the hole with grommet.
Yep. Yeah, and you can put a hole in any time. So.
Yeah. Any. I mean, no big deal. Yeah.
Yep. Yep. So the only other thing I need to bring up is the tolerance and bending. So usually if you say you want to take the dimension from the outside here, what the tolerance on that is going to be is roughly
Did we lose him? Tommy, can you still hear him?
No, he just dropped out, but his
Okay.
mic's not off.
Okay, so
So he must have lost the audio. Yeah, we just lost the audio.
We lost your audio. If you can hear us. Okay.
That's weird because you can see the stream still.
Yeah, interesting. Maybe it's a frozen.
Yeah, it looks like he's trying to reconnect there.
Left us on a cliffhanger there.
Yeah, I thought it's good that we start with a hardware topic because we were talking so much software the last times, so that you get an idea what on the hardware side is going on.
So the other aspect is how thin is that metal, because you're dealing with a weight issue when you're doing a pan and tilt.
Yeah.
Right. You need it as lightweight as possible. So how thick is that metal, or thin rather?
The metal is 4 millimeter. It's aluminum. So.
Why you bending?
His bending
This is something new. Yeah.
The bending idea is because it's in when you mass produce, or let's say if you make more than one, okay, then this process is much cheaper.
But 4 millimeters is 4 millimeters. This is not sheet metal, you know.
Aluminum.
Aluminum 4 millimeters is something.
Yeah.
To bend 4 millimeters, you need good tool, bro.
Yeah, it's that's basically the first question of Joe.
Yeah, this is
Whether
I never.
this is a
This is
do-it-yourself or not.
this is new design.
Yeah.
I didn't see this in a previous design.
Yeah, true.
Yeah, but
So-
4 millimeters to bend.
Yeah, you go to a shop, you don't do it yourself. So if you have to do it yourself, then you go with the previous design. So let's say make kind of a fittings, what we did with the bars.
Yeah.
But at the end, you always face the same issue that the PTF is a precise instrument, that any out of correct alignment gives you wobbles in your videos, and you don't want to see that. So and
My Discord froze.
yes, you were frozen.
My bad.
I think you first have to close your share.
Is it still sharing?
Yeah.
Oh, whoops.
Can I kick that?
Well,
Yeah, kick
one
that,
question,
please.
guys.
Okay, it's
What's
gone.
the weight of the telescope itself?
What?
What partner again?
What's the weight of the telescope itself? Just the telescope.
I calculated once 7.5 kilograms.
Oh, okay. That's heavy. Okay.
But it's very centered, so it's vertically expressed, not horizontally. So, and then Joe brought up a good point to bring the heavyweight motors closer to the center, as close as possible.
Yeah.
And how much are we thinking about only for this telescope mount itself? How much are we thinking about spending there?
Cost. Okay.
And cost, yes.
We set the limit for the PTF prefabricated, not do it yourself, because it has to be
Okay.
an instrument. To keep it below the 1500.
1,500.
Up to now it looks good, still looking good. Depends on how the boards and the availability looks. And the camera became a little bit more expensive than expected. So we went from 600 to 800. Not much room to move. So that's why I'm very happy that Joe went into this, because as it is an instrument, and let's say for 90% of the people, someone has to prefabricate it. And this can be a shop, this can be, let's say, a company, maybe like Tommy's, sorry, but some company can do it. Let's say if we find a partner that does it in the US, maybe we find a partner that does it in the EU somewhere, and can pre-produce this. So all the parts are, so what we would buy only is the forming of the sheet metal and the assembly. And then has to be a step to kind of a quality assurance. Someone has to check it whether it really works and satisfies the needs.
I have a
This is not
company
discussed yet.
I have a company I can recommend that I use here in Rockwall that has precision laser cutting, but they also bend and they do everything. They do all this stuff. So there's a couple companies. I'm in an industrial area, so we can reach out to a couple of them and get a price from them. You know, try and find out ultimately what it's going to cost. But I need a BOM in order to do it.
Yeah.
A BLM.
Once we get to some more nailed down,
BOM.
I can make drawings pretty quick, and making the drawings is going to be important too, because you have to put the tolerances on there, and a lot of people don't know how to do that. From my experience, going over other people's prints, so that'll help them produce it a lot better.
Yeah, and the other thing I was going to mention, I do know a couple of companies are on the West Coast that might be able to, help us out there as well. So,
yeah,
I can do some looking into that here a little later.
yeah. True.
So,
Yeah, I mean-
once we have the exact whatever. So,
Yeah,
I don't think that's a showstopper.
Yeah, I don't.
No, the place I work at can do all this stuff. I just don't want to say that I'm trying to get work for my business. So it's not, well, it's not my business, but
But it helps.
you know what I'm saying? Like, yeah.
Yeah.
Hey, Richard, why you choose 4 millimeters?
Because you need, from my point of view, from the design, but it's different from what Joe did, because Joe uses sink nuts. I went for threads in the material, in the sheet themselves. Although it's short, 4 millimeters for me it's a minimum for a thread to
Okay.
put strength on.
Uh-huh.
With 3 millimeters, I would not be so resilient. Relaxed.
No, I'm just thinking for a mass production, maybe better way use sheet metal.
Yeah, steel is
Thinner
an
stuff.
option, of course.
What do you think about that, Joe?
Yeah, I think we definitely go thinner, but I think that'd be a good spot once I get it more nailed down, start doing some simulations and stuff on it, kind of see where the weak points are, and then from there maybe we can start reducing the thickness down a little bit. Save on weight and cost and that stuff.
I mean, I'm thinking sheet metal is much cheaper and maybe pain in the ass to design, but for mass production is better, I think. I don't know what you think.
Are you thinking like stamped stuff?
Yeah.
Okay. Yeah, if you're going to go up in the 150,000 range, yeah, stamped is definitely the way to go. This kind of design is more in the 10 to 2,000, 3,000 maybe. But if you go higher than that, stamped is definitely probably going to be cheaper.
Yeah.
So, but when we talk about sheet metal, are we still talking about aluminum or are you talking about steel?
Steel.
See? And you're talking about aluminum. Joe.
No, Joe talking about steel, I think.
I think we just leave it up to when we get the quote from the machine shops, let's leave it up to them, because right now, steel, we have tariffs on steel, anything coming from China. So it's actually higher than aluminum right now. So
no, I have people from Serbia. Don't worry about it.
I'm just saying.
Yeah, I figured you went with aluminum just to save weight.
Oh, yeah.
Right.
Yes,
right.
that's my point.
But it is about twice the cost and half the strength of steel, roughly.
Yeah, and lighter, of course.
Yes. Yeah, half the weight, roughly.
What do you think about thickness? If we're doing this way with aluminum, about thickness?
Like I said, we can probably go down a little bit.
To 3 millimeters.
We just kind of
1/8
I'll have
or
to try it out.
1/8 or something.
Yeah, at least probably like down to 3 millimeters, down from 4, but
0.3. Okay.
yeah, because 4 is pretty thick. Like you said, if you're just trying to get threads in the aluminum, then yeah, it's pretty thick.
Yeah. Yeah, of course, with the pressed nuts, that's definitely a better solution. Okay. Hey, Joe, thank you very much. Thank you very much for your contribution.
Yeah, great work, man.
No problem. I'll keep working on it.
Good stuff.
Thank you.
I want to raise a subject that, I just share my screen. Why shall I talk so much? So I have to do this. Oh dear. And that. And this.
Oh boy, again software.
Again.
I mean, we hardware guys have no chance at all.
Okay.
This sucks.
Yes, you're right, Bojan. You want to talk hardware again?
No, that's okay. No, but
So, what I wanted to talk today is the system schematic version 3, and my focus here was more on a functional and the functionalities and the data streams. I hope you find yourself on this picture where your part is. Let me run you through. So on the very left top, we have this part. Can you see my screen? Shall I make it bigger? Hello, are you there?
Yeah,
Okay.
we can see
I
it.
can see it fine. I
Okay.
can see it fine.
Okay, thank you. So this red part here is the camera with the firmware, and Christian is working on it to get the firmware working with the driver, or the driver working with the firmware, so he does both the firmware and the driver, so that it is then being implemented in the NixOS package from IDO, so that it is then producing images. Please, IDO, Christian, if I say something wrong, please correct me, okay?
Yeah, so far so good.
Okay, I'm just moderating here. It's not that I'm speaking the truth here, please, okay? Jump in whenever I say something wrong. Christian explained me today that the GPS sensor has to be directly here on this Pi board, because when the data is created, it is also attached with the GPS coordinate time-wise, because from the GPS we get the timestamp that we rely on, and this is the time signal for the whole system. Then I'm not talking about the data right now. Then we have another part, just call it the CUDA brain, a board that has attached processor capability. How do you call this? Sub-processing capability. Let's talk about Jetson Nano, for example. There was supposed to be 3 parts that should run there. And please, Mike, please jump in, and Fabio if I'm wrong there. So this is my point of view as far as I did it by myself. So I hope to bring us on the same page with this. So on this, let's say the CUDA brain runs software that needs additional processing power. Let's say CUDA as an additional core. And this is the tracker, this is the kinematics classification, the image recognition. The reason why these 3 are positioned there is because all 3 use this extra processing power. Is this correct? Mike, is this correct? Does the tracker need CUDA to do its job? Mike? Yeah.
No. It doesn't have to have CUDA, but it needs some form of processing power. Yes.
Yes. Okay.
The classification bit will likely use CUDA. Yes, that will
Yes.
probably definitely use CUDA.
Yes.
And it kind of does make sense that they potentially sit on the same device, because then you're not dealing with any sort of network latencies or any of that sort of stuff.
Yeah. True. So the question we were talking today about is, in a prime meeting, is whether to take the tracker from the Jetson Nano and put it to the left on the Pi 4. First, because Fabio told us that he could make a 2880 square video stream running with being processed with a background subtractor, and he made it up to 40 frames per second. Right, Fabio?
Yeah, but that's on a single channel 8 bits. That won't even be close to what we need.
Yes, exactly. So it is out of question that the tracker goes on the Pi, because the Pi is consumed with creating the image stream, right?
The Pi will be consumed of creating the image stream and probably also the video stream.
Yes. Yes.
We'll see.
Yes.
Right.
Okay.
Yeah, I don't think it will be able to run the tracker also.
Agreed.
Tracker requires CUDA. I don't think how it's not. We might be able to run it without, but you won't get the performance or the parallelism that you need.
Yeah.
Also, Mike, we need to discuss more closely the support for Nano. I'm trying to run everything on it, and I am not as straightforward.
No, I know. I mean, it's something that.
Yeah. So.
So I think we should maybe just rename that to some sort of CUDA-enabled hardware or something versus Jetson Nano sort of.
Yeah,
'Cause
exactly. Yeah.
I think that device can be. It can be. It really depends on your budget, right? I mean,
Yes.
so it can be a Jetson Nano. It can be a Jetson Orin. It can be a full-blown workstation or whatnot sort of thing. So I think that's very much dependent on budget.
And maybe I don't know, maybe I'm being too conservative here, but I would go for more for the OpenCL thing than to the CUDA itself, because CUDA we are marrying with NVIDIA,
Yes.
and I don't know that if that's what we want, but if it is, then that's fine. But because most of the boards that we have from AMD, Intel, NVIDIA itself, even the ARM boards, they support OpenCL. Yeah, this it's the same thing as CUDA. It's almost the same thing. It supports most of the things that CUDA does, but it's widespread to the hardware industry. But that's just my opinion. But I know that we have some libraries that runs only on CUDA itself right now. So I don't know.
Yeah, I mean, the only reason. So I'll just kind of so the only reason for using the term CUDA is purely because of trying to do the image classification. Is so I'm not a like a data scientist or that sort of guy. So or neural networky guy. So all I've done really is to try and narrow the selection down a bit. Is I've just gone down the route of going, okay, the board we going to use is probably going to have CUDA. So and currently out there are a couple of projects. One is the Jetson Inference project, and another one is Isogros, and they both run on CUDA. That's the only reason. So if there's a different way of doing the image classification that uses OpenCL, then that's great. I just don't know. I've just not looked into that, So I've just been experimenting with the CUDA variant of it, really. That's the only reason. From my point
And
of
I
view.
think that the name is better, Richard. So we go away from the CUDA name, and if the CUDA is the way to go, then maybe we can it can just be CUDA. But I think we might approach other alternatives.
That's a very fair point. Yeah, no, that's a very fair point. I think you're right. I think we should.
So
Yeah, because in the end, if you can make it run on any kind of board with a coprocessor that can run, then it will be much better for. We have alternatives to run it anywhere. So
yes, agreed.
would it be feasible, Fabio, to make the software invariant towards hardware so that it can use CUDA when it's there and use OCL when it's not there?
yeah, that's feasible, but it depends on a lot of stuff. It means that, for instance, if you are using a specific version that runs only on CUDA, like for instance, like Mike is using right now for some of the image recognizing thing, then no. But if we can later, we might go for that for now, but we might later then search for some alternative that may be hardware independent, because like the library I sent you or the other day, the highlight library, it uses the hardware that's underneath. So it's if it has CUDA capabilities, it use CUDA, or else you try OpenCL. If it doesn't have OpenCL, also it runs only on CPU. So it does this kind of thing, but it depends a lot of what we are using. So If something that's dependent on the technology itself, then no.
Mm-hmm. Okay, when we stick with the status that we have right now, which is the tracker uses OpenCV calls and that uses CUDA, right? Mike, is this true?
Yes. So yes. Yeah.
Okay. So in this case, we at the moment rely on the existence of CUDA for this version, let's say. Maybe we develop a new version in the future where we say we are then hardware independent. But let's stick for the CUDA first. Fabio, would it be feasible to, for the time being, to use the CUDA cores with the tracker, the kinematics, the image recognition, all on the same board?
That I don't know. We have to figure out. Mm-hmm. What I'm trying to do right now is I'm just finishing up with the background to the tractor, and studying some of the other libraries, and then I will go for the tracker to try to make it as fast as it can be, so it not be it will consume less CPU mm-hmm. than a normal thing. Mm-hmm. So we need to try to squeeze as much performance as we can, so we can try to run it on a lightweight design thing. Mm-hmm. So if we can do that, then we might be able to squeeze some more performance for the image recognition and the other stuff with CUDA on the board. But we need to squeeze as much performance as we can from all of the necessary software.
Yeah. So you mentioned background subtractor that you tested on the Pi, right?
Yeah, I did.
Yeah. So I'm a little bit confused. Maybe you all can give me the right picture of this. I'm addressing Christian, Ido, and you, Fabio, and Mike. Sorry, Mike. The background subtractor, from my point of view, is part of the tracker. And if it's not, if it's is it a pre-process? Is it a step one, and then comes the tracker? Or is it a kind of a loop that it's always jumping between these two, the tracker, the background subtractor? How is this working? So I can understand where the background subtractor actually belongs to. You know what I mean?
So so in my opinion, I think it's part of the tracker. So I think it basically is a ROS node that integrates with a tracker.
Yeah, that's the first. Let's say that's the first phase of the tracker.
Let's speak about definitions first, okay? Because I get confused when you guys speak about the tracker, okay? When I speak about the tracker, I speak about something that can receive, plots of different sensors and then create a track by fusing these plots together, right? Now, in my view, a tracker doesn't rely specifically to a camera, because we have other stuff that can create tracker. For example, ADS-B or RF or I don't know, some other sensors that we will put in that can detect something, right?
Okay, so we are talking about just the image tracker. Okay, we're not talking about.
I don't think we need a specific image tracker. I just need plots from the image. Where are the objects? The tracker needs to be a higher order.
No, but that's what the tracker is. The tracker is something that looks at an image, then sees that thing is not part of the background, and then it goes to another part of the algorithm that starts to tracking that specific part of the image. So tracking that part of the image, so we know that we have something there, and then we can figure out a way of putting together the other information to see what that thing is.
Yeah, but that's the tracker. What is it in the end? In the end, you're going to have some vector, right?
Mm-hmm. The JSON vectors,
that's the input. The input for the tracker needs to be like a set of vectors, right? It doesn't.
I thought the tracker
it doesn't need to understand
the
an
tracker
image.
is producing these vectors.
The tracker needs to produce. The tracker needs to produce fused. Right.
So we have a lot of different tracking. For instance,
yes.
If we're so what happens is that, for instance, we might start tracking an object based on an image, or might start tracking an object based on the passive radar. So each of these are different ones that starts tracking something. But we start with something, and what we're starting with is the image. So we start with the all-sky camera image, and then if the all-sky camera image sees something, then we start tracking it. Then we put together all the other information for ADS-B and everything else together to try to figure out what these
again.
object being tracked.
Let's go lower. No, this is too high level. Let's go to the details. Okay.
Okay.
When you speak about the image, I said the tracker track the image. What exactly do you mean? What is the data structure you're working with?
So I think Mike can say it better.
Yeah.
Because if it doesn't have pixels in its brain, okay, we should take it out of the camera and it should be of a higher order. Because we can utilize it. Now I understand there is like a sensor type that will tell you what is the accuracy and how can how the fusion should work if it's like a bigger threshold or a smaller threshold. So how it will fuse when, for example, with another threshold, with another sensor.
But
right?
So I don't follow.
Ido, you are talking about a total different level here. You are talking about the event tracking that fuses all trackings together. Let's say the passive radar plus the visual plus the whatever have you. We are talking here about only the fisheye tracking. This is only.
It doesn't matter. It doesn't matter. Tracking is tracking.
Yeah, we got to get an alpha out, dude. So
I understand. So but again, this is very confusing. Okay?
Yes. Okay. In this case, we call this different. We doesn't call this a tracker then.
Well, I don't know. I mean, it tracks an object that is. It tracks an object across the screen. I don't know what else you're going to talk. What else you're going to call it?
No, you're exactly right. It tracked an object, but that object doesn't mean it needs to come from the fisheye. It can come from other places as well.
I mean, you got to.
But this is a different way of tracking. This is event tracking of a higher level, Ido. We are talking.
No, no. Tracking is tracking. There is no like event tracking and
wait a second.
Tracking. That doesn't make sense.
You have to explain how you see it, because we are all totally on the wrong on a different page.
Okay, let me see if I can share something.
You want to share something? Okay, I stop sharing.
Yeah, I'm not saying to change anything now, but when we discuss this stuff,
we have to discuss.
It's very important to understand the growth for it.
Absolutely, that's why we do it. By the way, Lionel, hi. Didn't say hello yet.
Yeah, unfortunately.
And for the daughter there.
Let me see.
I should be back.
Yes. By the way, Bojan, I like your style.
I'm just kind of really worried we're just making things very complicated, you know.
Okay, so let's not forget about it. Let's discuss it after we do alpha.
Yes. Let's first discuss before we decide what to do.
I kind of think that's probably a good idea. I think then we can just checkpoint and and maybe put together a set of terms that mean stuff that we all know and you know, all call things by the same name.
Makes sense.
Yeah. Well, if I could jump in with a kind of reiteration of what I think I heard and see if I'm on the right page here. Essentially, at present, the model that we're working on is the all-sky camera and its related Raspberry Pi are doing the basic generated track, and then that's getting fed off to either the actual thing marked MCP, the actual tracking camera, and I'm hoping I'm correct there so far. And then it's also spitting out a line over to a nano, an alternative processor someplace where we can, do analysis on it, but we can also integrate in these other things like ADS-B, passive radar return, any other thing we're seeing. Is that more or less the kind of model everybody is working on? Is my basic question there.
I see what the point is, that it is sensor fusion, let's say, where all sensors fuse together and there's one tracker that keeps an eye on everything, no matter what the data is.
Exactly.
But we're not there yet, Ido.
And that's how you set also priorities. That's how you can do filtering. Yeah.
Definitely. This is a higher goal, and we want to be there. But let's say this is not something in the first alpha version. I don't see this in the alpha, because that would postpone the alpha certainly for 2 years.
Yeah. Well, like I said, fast question. Do I have essentially where these blocks are occurring? Do I have them placed in the right box there on your diagram? Or did the question not make any sense?
I'm sorry, what?
No, he's talking about my diagram.
No, I'm just trying to make sure that I'm
rearranged.
Well, not by much, I don't think.
Yeah, so my view is I think this stuff might change once we release the alpha version, because I think we'll get feedback. It might be that we need more processing on the one side, or split things out to try and process things faster and in more like a parallel fashion. I think I'm not sure if I'd get too constrained by the diagram at the moment. I think maybe if we get the alpha out and then kind of see what the feedback's like, and then we can redefine all that stuff.
Mm-hmm.
Yeah. Okay. Well, like I said, I was just trying to make sure my understanding of where things are happening is essentially correct at this point. I'm not trying to propose any change of anything that's going on. I just want to make sure that what I think is happening, like on the all-sky camera, on the Nano, on the other Raspberry Pi for the MCP, the software blocks that I'm thinking of, if that's where they actually reside, at least at the moment. And I know it's all subject to change because, this afternoon somebody goes, we could do this, and it would, magic and everything would be great.
Yeah,
so I'm just trying to make sure.
But I think
I'll get my elves right on it, But I'm just trying to make sure I'm on the right page, and my thinking is correct that, this is what's going on the all-sky node, this is what's going on the Nano, this is what's going on over on the MCP.
Yeah, for the current version, for the version B. So, yes. Yeah. But I think Ido is totally right to have a sensor fused system in the future, absolutely. But I'm also giving right to Mike, because we need something tangible that we can work on step by step. Nobody wants to plan 2 years ahead, and we need something that is quicker coming to life, let's say, so that we can make small iterations, which is much more satisfying for us and also for our community. So that's why I think this step-by-step approach, as Mike said, it is certainly the way to go. But of course, we have to keep the perspective ahead, and that's why Ido, are you sharing anything?
No, I'm about to.
Okay. But I get your perspective. But in this case, right now, the schematic is version 3, and it's still pre-Aloha. Okay, this is not the final goal. Please don't see it that way. That's what I want to say.
Agreed. Yeah. I yeah.
So in between we are waiting for Ido to share the screen. Coming back to the system as it is in the version 3, lower, okay? The background subtractor. I thought that the background subtractor is part of the tracker, is the fisheye tracker, let's call it that way. And maybe it is a second node on that particular on that platform, on that board. It's the background subtractor board. But if it's a background subtractor node, would you be able in the tracker to call it so that you get the real results in time, so that you can process in, let's say, 15-20 frames per second? Is that feasible, Mike?
Yeah, so it is currently set up that there is a background subtractor node, and all it does is it does background subtraction. So yeah, the entirety of the tracker currently consists of about 10 to 12 nodes. I can't remember exactly, and they all do different things. But it's really, so the idea behind that was that if, for example, we can do the background subtraction on a say we're running out of processing space on a nano, and you want to do the background subtraction on a Pi, you can run a version of the background subtractor that is specific to the Pi. So it runs really quickly on the Pi, but the application as a whole then just consumes that information from the node that's running on the Pi, sort of thing. So that's why it's good to keep these sorts of things independent. Yeah. So and the same applies, like if you run it on a, if it's GPU enabled, be it CUDA or whatever, you can run it in a configuration whereby it leverages the hardware acceleration that it has.
So basically,
without other parts of the application having to be dependent on that, if that makes sense.
Yeah, but your use of these nodes is a sequential one, right?
Yes. So yes.
Okay.
Yes.
So the background subtraction
so there is sequencing
se
going on.
Pardon me?
There is a sense of sequencing going on. Yes.
Yes, and the background subtractor is, let's say, a preprocessor to all the other tracking nodes, right? It's the first one.
Yes.
Okay.
So
got it.
Yes. So I still need to do your diagram. I've just realized that. So I do. So what I'm working on at the moment is just trying to standardize all the message types from. So I've put together like an issues list on the GitHub repository, and I'm just going to work through those. Matt's asked if he can peer review them, so I'm going to ask him to just have a look at the pull requests and those sorts of things. But basically, yeah. So I'm moving towards alpha. Essentially, I'm just kind of standardizing on message types at the moment, integrating external, like community specific packages that like the like a USB camera sort of package, and something that can play a video file. So I'm trying to use more community driven packages versus everything that I've done, because they are better than some of the stuff that I've done. So and that's why I'm just trying to standardize on message types.
Okay.
Sorry, that was
too much detail, I think. No, absolutely not. So that means, I shared my screen, Mike, I hope you see it. So what we call the fisheye tracker or Sentinel or simple tracker includes the background subtractor, because let's say this package, it's a package of ROS nodes. It's not one ROS node, it's 12 ROS nodes.
Yeah, so my view is that the background subtractor will be really good at defining a target. The goal in my head is the background subtractor is used to define a target, and then stuff like kinematics and image recognition and all that sort of stuff is used to discount a target. So if we find a target that we are interested in, and then we can use other tools at our disposal to determine whether the target we are interested in is a known object, like a plane or a bird or a whatnot.
But Mike, in this case, you're already talking about the higher level event tracking, because this delivers.
Yeah. So let me share a screen and I'll
yes. Hold on.
Let me share a screen and I'll explain.
Hold on. I have to unshare. Yes, unshared.
Okay. Can you share? Can you see my screen?
Coming. Yes.
Okay. So this is what I'm very familiar with. So the idea, we have sensors on the left. Okay, each one they produce whatever, but the goal is to transform whatever they do to what is called like object detection or plots, right? From that, the tracker takes this object detection, either fuse them together to a target already. If, for example, the fisheye and the passive radar detect the same thing in the same location, you can create immediately like a target with two sensors, or you can create a track for each of them, and then the target will include all the tracks that it has inside. Mm-hmm. So you have an entire history from all of the sensors of what is happening. Mm-hmm. Now, the main difference between a target and a track doesn't really have still like it might have classification stuff. It will not have priority, right? So it will not be something that you will have the telescope start slewing against. A target will be the one that the telescope is interested of. Okay? But again, when you publish the target, you publish also all the tracks that this target has as part of the situational awareness. Okay? Does that make sense?
Yes and no.
Okay.
Yes, it makes sense in a. Okay.
Now more than that. Okay. Now more than that. Because it's a real-time system, every sensor has its own kind of times for how fast it can produce like plots or objects, object detections. Mm-hmm. But the tracker is working very, very differently. Mm-hmm. The tracker needs to create a projection for targets. Okay? Because you want to have high accuracy on how it moves, you always want to update the target and says, hey, this is the route that I'm thinking it's going to take in the next, X seconds. Mm-hmm. And you keep updating that and every time, you get more accuracy from the real sensors with the new real information, and you correct the track, you also correct the target, and improving its predictions.
Mm-hmm. But the input for this tracker.
Because in the end of the day, what the telescope will be interesting, it's the projections of where the target will be X milliseconds from now.
Yeah.
Not where it is right now.
Ido, may I interrupt you in this point? What you're talking,
yeah.
You're showing here, this tracker is for me a part on the master control program on that platform, because it's on the meter level. It sees all the other sensors. What we were talking about now is only the object detection that was only for the fisheye. We're talking about the first one, object detection.
it's just a different name. Yes, totally agree.
Exactly.
You might call it object detection.
Okay, that's where I get confused, and I wanted some clarification. Okay, but bear in mind, okay, the tracking, specifically if we put the passive radar in it, that will be heavy computation to do the fusion.
Yeah.
That won't be a straightforward thing.
No, of course not. That's the harder part.
Yeah, totally and that's probably will need a CUDA also.
But there's a pre-processing.
Sorry, my understanding is.
Go ahead.
Sorry.
No, go ahead.
No, I was just going to say some. My understanding that is where something like NVIDIA DeepStream comes in, because its job is to take a feed from several different sources and essentially fuse those streams into a single stream, which then gives you events and that. So that I know that's a specific implementation of the sort of fusion
So when
element that you're referring to, but
so when I speak about the neural network, okay, this entire thing is the neural network. When the background actually the plots are kind of the input on it, the background substance should be inside of it. Okay.
Mm-hmm.
So this needs to be all of this needs to be inside the neural network. Now it doesn't mean that it's one compute, okay? But it means there is a processing pipeline that is running under a neural network.
Mm-hmm.
yeah, so I don't quite understand that. So that's the bit that I struggle with. I can't visualize that. So what I can, so that will need to dig into a lot more detail down the line, I think.
You're just increasing the dimensional space of the neural network, and you give it special node configurations. That's all. It's just it needs more process power. It's more complicated.
Yeah.
But it's okay. Yeah.
I mean,
that's as a final goal, because it will become easier if more sensors are added, because then it's just another one. The first setup is crucial.
You will have to. Yeah, then you will have to do the kind of the mathematics for each sensor, how it's going to get fused with others.
Yeah.
Right.
Yeah. The configuration of each, and then
the
validation, the prioritization. Anyhow,
it's like for example, there is a different accuracy between the fisheye where the object is compared to RF, right?
Yeah.
To for example, like even GPS anomalies, if we want to put it later on, right?
But I understand that you fuse everything together and let the big processing do on a central node. Versus the idea of having a central tracking element, that's like in your case, and you even wrote it beneath, tracks and targets. So let's say it consumes only tracks and targets. In this case, it would not have to consume the incoming data and process it, centralized, which is, from my point of view, kind of a blocker. I would decentralize it and let each sensor be a part of itself and process its data.
Yes.
And then output tracks and targets, which are then fused together by the central tracker.
No, it outputs like either plots or object detections, and then the fusion will create the tracks.
Call it that way. There are already tracks within the object detection as well.
Not really. There is no reason for it to look at history. If it's frame by frame, you don't look at history. You just see this is where the object is.
Okay, for example, passive radar plots. If you want to process total passive radar plots, then you delay a lot of traffic data stream onto this central node. In the case as Bob, you're not here. I hope when you hear this, maybe you can correct me. He already implies that there is a processing subboard implemented. So what he calls the passive radar is already the Kraken plus an external board that processes the streams and outputs tracks and targets. So if that is already a node and gives out the tracks and targets, why extrapolate the data and the processing to a central node where everything is fused together and just increase the central node?
So here you need to understand why radars are giving you, they don't give targets, but they give tracks, and you're right.
Yeah.
They give plots and tracks. They give actually tracks, and each track has all the plots that actually conform this track, right?
Okay, so a plot is a track in your case.
No. A collection of plot is a track, okay? But it's a radar track. It's different, okay? Because it's how radars work. So usually the radars, they have how it's called, like they have different. I forgot the word for it, but think about it. They have different channels, okay? when they scan reality, right? Now sometimes they have a plot jumping from one channel to another. Okay, so when for example a car will cross the road, it can move from one channel to two channel to three channel, four channel, whatever, right? Okay. Because the radar does a scan. Yeah. Right? It always runs on one channel. It always switch between them. That's how the real time internally works. Yeah. Okay. So it could be that some plots will move from one region to another. Yeah. That's the only reason that the radar have a tracker inside of it to detect that and tell you, hey, this actually plot moved, or I think it moved. Now it's not always accurate. That's why you always want to have a higher order tracker to fix that. Yeah. Because radar has a lot of issues. Because of how RF signal moves. Sometimes you can have feedback. Sometimes you can have duplication, like a clone. Sometimes the signal completely vanish, right?
But are you implying here that the central node is re-evaluating the output of
no? So what I'm saying, this is something specifically that the radar is doing, okay? But in order to fix that, you usually want to put two radars to eliminate all these natural causes. When you put the two antennas in two different distances, that's what the Kraken is actually doing very, very well. It's eliminating all of that internally. So we will receive most likely from the output of the Kraken immediately tracks. So it's objects with track that the fusion can take and decides to create targets right off of it.
Yeah,
but that's specifically for...
It receives tracks, right?
Tracks and plots inside of it.
Right.
Yes,
we are not talking...
Because the amount of plots is just probably gigabytes.
Yeah. Per second.
Right? So we are speaking... again, radar works very, very differently in that regard.
But anyhow, how it works, the output of radar, of that possessive radar sensor, is tracks and targets, right?
Tracks, not targets.
Yeah, okay, call it tracks. But not the raw data from the radar.
Again, think about target is something that you want to chase. You want to slew against.
Exactly. The output of a sensor is always a track. Let's say always. In most cases, it is a track. Okay?
Call it a blob then, maybe. So should we? Because we need another. We kind of need another term here as well, because we need something that essentially identifies something like a point of interest, which then is tracked, which then becomes a potential target.
So the target has the point of interest. That's what the target is. Okay. The track
I don't.
So think about it this way. If you have an airplane flying in the sky, okay, and I have 10 frames on it, I have 10 object detections, okay, and then I have one track, okay, that is telling me this is the history of all of these objects. And then I have a target after let's say 3-4 frames, okay, or even one, it doesn't really matter, that says here, this is the target, that's the priority of it, it's an airplane, whatever, and that's the track of it, and all of the object that it has.
I don't know. I got to write this stuff down. I'm not, but the way I see it is you have to identify something that is trackable. That basically.
So to track something, you need to have a history.
Correct.
Right.
So what is the thing? So what is the thing before the track then? So that has to be
the object detection.
So you've detected an object, and now you've determined. So you detect 5 objects, and you've determined that, and you detect them across several frames, and you've determined that one of those objects is the same object. Therefore, it now becomes a track.
Yeah.
Yeah. So now comes the question: how do I know that it's the same object, right? And that means that now the object detection needs to have coordinates, and it needs to have a vector, which means like what direction it's going and what speed, right? In a way.
That's the output of the tracking, yeah.
Yeah. So sorry, I got confused. The output of the tracking. Yeah, you have a coordinates on the object, and then from how the tracking fusion should work, it gives you like that vector.
Yeah.
So as soon as you have a vector, you can actually say, okay, this vector is, I have enough confidence in it that I can actually create a track and start and give it a priority and start assessing it.
Mm-hmm.
Like I already do. I mean, I know it's not, part of the mod, but I already do that sort of thing, right? I already do where we essentially identify a blob, which is, we then pass that, that detection into the CSRT tracker. It then tells us it knows about this object and this is the track associated with it. And then we basically, after a period of detections, we determine that it's a good target or a good track to follow because we've had some history, and then we try and follow it. And that's the whole, when you see in the video and you see like the track history, which is yellow, then it turns to green, and then there's a potential time where the tracker almost gets bored of the object because it hasn't moved or something like that, and it goes to red. So there is some of that logic there already. I know it's not part of the fusion stuff, but we already do that sort of thing. In what we call as the tracker.
Yeah, so that's why I'm saying like the tracker is actually you have both, like all of this as one, right? In the future we will break it apart because the tracker will require different like probably compute because it will have a lot of data. Okay. But yeah, I mean, also the coordinates will be. I think right now you don't have coordinates.
Well,
local coordinates.
We got X. Yeah, we got like X and Y.
Yeah, no, so that's not the coordinates. We need to change it to I don't know, Cartesian coordinates or no, you have Cartesian.
He always
we have to change to Geo.
Wait a second, Ida. He's working on the fisheye sensor, and he has only local coordinates. It's only intrinsic to the view of the fisheye. So we only can have X and Y. We can translate that into elevation, let's say, and direction. But it's just a formula. Wherever you need it, any node can do the correction. Or
elevation you won't have, but we will need like I guess geo coordinates.
Yeah.
If we want to fuse it together with like a GPS tracking from an ADSB.
The fisheye doesn't have distance. At the time, he only knows local coordinates. So he cannot. The fisheye tracker is not giving you the coordinates. You
can still create a coordinate, but with low confidence, and that's what we are looking for.
Okay.
Because the lower the confidence, the easier to fuse it, right?
Yes, of course, you can do it on the fisheye as well. True. Yeah, like the Ukrainian did it with light estimation. But let's go back to where we actually started from, and I wanted to talk about the Aloha, the schematic version 3 right now, and what the future will be. Sorry, I share screen again, so I do not talk with hands. There it is. So, okay, let's focus on this part again. I call it now the fisheye tracker. It's not the event tracker that you were talking right now. You were talking about the mechanism that is central, where all nodes go in. we were talking about now here only this node, which is the fisheye node. This is only about fisheye here, this left part, right? So that's why this tracker, I call it now the fisheye tracker.
Well, I think until we have another tracker, you can call it the tracker. Until we have
or
something that tracks, all that other stuff. I think then we can start differentiating between trackers. But up until that point, we only have the one tracker.
It is funny. I never expected that to be a topic that we talk about, how we name things. Okay, this fisheye tracker.
That's a fair point.
Sentinel, simple tracker, whatever you call it. You have it consists at the moment of 12 nodes. In the future, either it will be separated and parts will be put on other platforms and put in a different way together, right? Can we stick at that point, Ido? Are you okay with that? Okay. So
yeah.
I'm now only talking about the Aloha version as it is right now, that we can put it out as fast as possible. So, long story short, the fisheye tracker as it is, with the 12 nodes that you created, the output is, for now, it's the JSON and 64 by 64 pics, right? That's one of the output of the nodes, right?
Yeah, so it doesn't output that yet. So because I don't think you might. I don't know if you would need the JSON.
Yeah.
Because so I don't know if you would need the JSON, and I don't think you would need the thumbnails either, because I think you would have another node that subscribes to a topic where that sort of data is published. So the data that goes into the JSON is currently outputted.
But in this case, the cropping had to be done by a different process. From the same data stream again. So doing the work twice. My point is...
How do you mean twice?
Your input is an 8-bit video stream, for example. And you create the JSON file because the JSON consists of the timestamps and the vectors. At the same time, you have the stream open and you can crop out, frame-wise, you can crop the events out. Whereas another process has to resubscribe to the same stream and do the cropping. I'm just talking about performance. Well, it makes more sense that the fisheye is giving out the pics instead of another process.
No, well, it'll be a node that is, so it can be a node that is part of the simple tracker set of nodes. Mm-hmm. So that's not a problem.
Yeah.
Well, so I think I'm overcomplicating it. So I think essentially the data that is used to do the cropping is currently available.
Yes.
So it is. This is now going to get more complicated now because I'm going to refer to old simple tracker. So old simple tracker. Yeah. So old simple tracker produced JSON and thumbnails. I implemented the ability to dump thumbnails of targets and that sort of stuff in old simple tracker. I've not done that in new simple tracker. One of the tasks or one of the issues I've got on my list is to try and determine the best way to save a track. Because like in old simple tracker, that would be essentially a video file, a JSON file, or a bunch of images, or a bunch of videos, a JSON file, and a bunch of images, and all that sort of stuff. I think in the new tracker, or the ROS 2 version of the tracker, there are different technologies that we can use for that. And one of the things I want to explore is using a ROS bag as a storage mechanism. Mm-hmm. I think we've kind of discussed this sort of thing in the past, because there was a ROS bag, and then there's also a is it a DD the fast DDS or whatever, the fast DDS data stream thing. So there's also a recorder that comes with that. The guys that implement the fast data stream, they also implement a recorder, but that is not free. That is something that you have to pay for, whereas I think the Rosbag stuff might be free. So I'm going to go down the Rosbag route initially to see if I can get it to record tracks.
Mm-hmm.
This is all for the alpha. All this is subject to change going forward.
Mm-hmm.
But initially, that's what I'm going to look at.
So one of your ROS nodes will then output vectors, so event-wise. So you subscribe to your nodes so that the output is event-wise. So when an event comes in via this ROS message, it has an event ID and a track ID, because it belongs maybe to a track, and that only the Fisher track can decide on that. And it has a timestamp and it has a vector, right? Is this true?
Yeah, yes. So So that's so it currently is, yes.
Okay.
I'm changing message types now,
Mm-hmm.
and I'm going through a process of refactoring to support or use community-driven or standardized message types.
Mm-hmm.
And I've just got to see if I can capture that same set of information.
Mm-hmm.
So yes, the intention is to do that. Yes.
Yes. My next question is, this 64 pixel images, these cropped images, would that be feasible that you implement this as a ROS node? Because you have already the stream open, so that, let's say, the kinematics and image recognition can subscribe to? So the image recognition part can subscribe to
yes. So
pixel output.
So the kinematics is probably not going to need that, because it just needs the location data or the
vectors,
XY coordinates, and do its, try and make its determination from that. So if there's, I guess the question is, do we need the image crops at real time, or do we just capture all the information across the entire ROS system when we have a track, and then we can replay that entire track, and if we at that point decide that we need to crop the images, we can. I don't know, Richard. That's still a point of discussion. I think is the point I'm trying to make. I'm a bit woolly on that. So there's probably a set of requirements there which I haven't implemented yet.
Yeah.
And it's something that we can discuss. Yeah.
Yeah. Now my only concern is that a secondary process would have to initiate the same ROS commands as the fisheye track already did by requiring the stream from
so it's actually really quick, that sort of thing. So it's not gonna so these things run as independent processes.
Mm-hmm.
So so if you try and do the cropping as part of an existing process, that's going to take up compute cycles for that process. Whereas if you do it at a separate process, you then don't tie the current process down, sort of thing. So it swings and roundabouts, really. The subscribing to the image there's no real overhead on that, because
okay. Yeah, let's be there.
So I wouldn't worry too much about that.
Yeah, okay. Maybe I'm over worrying this. Correct. Let's be there.
Yeah.
So the input for the kinematics will be the local vectors and the timestamps. The input for the image recognition will be the timestamp and the pictures. Okay.
Yes.
On this part, we are on the same page, right?
Yes.
Okay.
Yes.
So I'm coming back to square one, and now my question to Fabio. Are you still with us, Fabio?
Yes, I'm here.
Okay, thank you. These three elements, would that be feasible from your point of view to bring that all on one platform like the Jetson Nano? In this way, in this constellation as it is, with just these simple ROS2 calls from the image recognition and the kinematics doing their business on small data amounts?
Yeah, I would imagine so, because right now the background subtractor is taking almost nothing, very little time, and I can optimize the tracking imagery a little further too, and then we can make it run on just one platform. Yeah, I think so. Yes.
Okay. So I'm just talking about feasibility. Okay, it's not anything that has to be done tomorrow.
Yeah. One thing that would be good is for me to have some access to at least a Jetson board or something like this. If you have some of these things online, so I can test it on there, it would be great.
You need a Jetson board. Okay. Let me make a note. Okay. I will try to send you a Jetson Nano because it is the smallest. That's why the challenge is bigger.
No, yeah, and the thing is that because since I'm doing a lot of the optimizations I'm doing is specific for a kind of problem and hardware, it's good for me to have something that it will be like working on.
Definitely.
So I can make sure that it will be targeted for that hardware.
Yeah, definitely. Okay, Yannick, are you there still with us? Yannick? Sorry, I have another screen open. That's why I don't know who is there. Oh, Yannick isn't with us.
I think he's left the building.
Okay, he left. Okay. So yeah, Mike and you are since about 2 weeks you're working on test going into the neural network, the image recognition part in this, right?
Yeah, so I've put that on hold now until I want to get there's some stuff I want to do on the simple tracker, the ROS version of the simple track or the tracker. I need to get that out of the way before I look at that stuff any further.
Okay, perfect. But I think my Yannick is not here. But Yannick did some tests, and yeah, he succeeded already with a simple model that he used because it's still on the 64 pixel images, and he could, with a probability, he could differentiate between planes and birds. So I think it's feasible to implement this in the lower version as well, or not? Just a question.
Okay, we can try. Yeah,
we can try.
No,
okay.
That's fine.
Okay.
Yeah,
but it's not
I
a blocker if we don't have.
Sure.
Yeah. This actually basically the same with the kinematics. It's also nice to have, but not a blocker for the LOR.
I think, yeah. So I think at some point, Fabio, I need to have a chat with you so we can try and get your version of the background subtractor built into the container, so I can start using that as well.
Yeah, perfect. Let's do that.
I think that is probably, because it's such a speed up, I think that takes precedence, in my opinion, to the and then so like in my head I sort out the ROS version of the simple tracker because that's in my control. Then we need to get the new background subtractor integrated so that I can use that, and then we'll get the kinematics integrated.
Yeah, let's talk this week then. Let's just schedule a time, and then we can talk, and then we see that if I need to put some sort of Python wrapper to the library, or I can just run a ROS2 node in C++ just to do the background subtractor. Maybe which one is faster?
Yeah, you can definitely do it via the C++ route, for sure.
Yeah, because that I think it will be faster for us to go if it's just for it.
It kind of this is more, so this, I guess this is more down to not so much technical, but more from a project standpoint is that is like the sort of language that you want to standardize on. If you want to standardize on Python, or if you want to just use whatever is best for the job, sort of thing. You know, Richard.
Yeah, I got it. The Python is I think at least for scripting the nodes together will be good. I should wrap the library in a for Python also, but it's something that I never did. It will take some time for me, but that's fine.
Okay.
I think for the time being, we should go as Fabio prefers, because at the end, IDO, you have to make an image from that software anyways, so you have to recompile anyways, right?
Yes. So regarding that, there is no way to get a Nix image for the Nano. Okay, I have a basic image, right? A base image for Sky 360 for the Pi. I'm working right now for the x86-64, but I won't be able to do it for the Nano. So for the Nano, if we want, I think the best will be just to use, the old kind of image from NVIDIA with Jetpack 4.6 and Docker, and then run everything.
Yeah, or let's say, Fabio, for example, if I send you a Jetson Nano board and you can make the software run on that, we just drag an image from that and anonymize it.
Yeah, I will make it run as fast as I can on the Nano. That's my goal.
Ouais. Aucune idée, je sais pas. Ah ouais, les petits trucs blancs là. Ouais, ça arrive.
Did someone say something, or was that Lionel? Okay. Anyhow.
I think it was Lionel, yes.
Yeah, it was Lionel.
So, Ido, this is from your point of view, okay, if we go that way? Let we go with the Jetson Nano board, and Fabio tries to make it running, and we drag an image from that board and anonymize it.
Yeah, but then that will be like a custom script that people needs to run.
Yeah, kind of. Yeah.
Okay. Yeah.
Or we, let's say, first startup runs automatically. Kind of.
But again, that board, as Mike said before, it has no support whatsoever. Yeah. They actually removed.
Really?
I was surprised. They actually removed the code to support the model numbers and everything from the Jetpack. It's really not supported. It's not just
I did mention that previously.
Yeah.
I did try to get that point across to you guys.
Yeah. I didn't believe that, but they actually removed the code to support the board.
Yeah, it's nuts.
Yeah, what is the solution then?
So there is going to be a new Nano, Orin Nano, but it's not out yet.
Yeah.
I don't know the price tag. That will be supported. That I can actually, I will be able to create an image for that on Nix. But yeah, to support the old Nano, that will be a lot of work. And actually, it's a very old board. So.
Okay.
Yeah.
Okay. Yeah, that's my next tasks, to procure Jetson boards. All right. Hey, last question. We have 6 minutes to the clock. Anyone who wants to raise a question?
Yeah, I have a question, Richard.
Yeah, go ahead, Joe.
So it's kind of a question / suggestion. So when you find a thing you want to track on the fisheye, how does that go? How does that tell what the pan tilt mechanism should look at?
Yeah, maybe Christian can.
Like, how does it control the motors?
Christian, can you explain this? Christian, you there?
Yeah, I'm there.
Okay, perfect.
Okay. The thing is, if an object of interest is detected and classified, we have to calculate an interception course in right ascension and declination as coordinates, and this interception course is passed to the PDF. and then it's loose there. And if the calculations of the path are right, then it should have been placed in the middle of the field of view.
So it doesn't take the image and then say, "Oh, my object's 1 degree to the right. Move the mechanism 1 degree to the right," or does it kind of?
No, we have to pre-calculate an interception course. It is hard when an object is moving with a rectangular angle like that. But normally things don't work like that. Even a UFO that is capable of doing right turns rectangularly, during the time the telescope takes to slew there will be several redirections, and this comes in handy to calculate the correct interception course. And because
how do
we
you
can move the telescope very, very fast, we can be there in time.
So how do you coordinate or calibrate the two cameras together? Because my main concern is like when you go to assemble it, you say your telescope is aiming 1 degree higher than what the motor thinks, and then maybe you put your gear on 1 degree off. Is there like a calibration that you can do to initially put them together, or?
When the telescope is in place and the object is detected from the camera of the PTF, then you can log on it. And this logging algorithm and tracking algorithm has to be built yet. It's not there.
Okay.
But slewing there, having an interception course and slewing there, this already is in place because the telescope tracking system is already in place. It's already invented and in form of code, and we can just use it.
Yeah.
It just needs coordinates or an interception course.
Maybe I can put something in. This is a two-way tracking. So one tracking is on the fisheye, where the fisheye says, so there's a certain elevation and direction, there is something. And the central master control program says, okay, this event is of such significance, we send the PTF to it. Then what Christian said, this path, this meeting path, let's say if you shoot down a rocket with another rocket, it's the meeting path more or less calculated in advance, and the PTF is slewed to it. But then there's a second part of tracking, that is the PTF tracks itself, so it sees the view and tries to keep the object in the center. Because the tracking from the fisheye is not that accurate as if you have it to keep it just in the center.
So can I correct a bit? Okay,
please.
Going back to the fusion ID, right? So now we're speaking that we have what's called a low confidence fisheye input and a high confidence PTF.
Yes.
Right. So what it means that if there is like an inaccuracy of a degree, and I think degree is actually a lot, but between the fisheye and the PTF, the fusion will happen closer to where the PTF sees the object rather than when the fisheye sees the object. Does that make sense?
Yes. Yeah. So basically, you take the image from the zoom telescope, and then you can use that image to fine tune it, I guess.
Yeah, exactly.
Exactly. Yeah,
so
exactly. And we're using the same fusion engine with the same algorithms to do that.
Okay. So say the mechanism is off 1 degree constantly, just by the way it's manufactured, tolerances, whatever. The software can make up for that, basically.
Yeah.
Okay.
The telescope has with its magnification of 37.5 times, has a field of view of about 1.2 degrees. So if the object is pinpointed somewhere in the field of view, then the telescope can lock onto it and place it in the middle. And this is enough. So The accuracy for the interception course should be around 1 degree.
Okay. Sounds good. I like that idea.
Yeah, this is how it's done in astronomy for the last 30 years. And in radio astronomy too, so this is no big
border
deal.
protection.
Yes.
Where? So
border protection.
Yeah, no, but I asked where, which border? Okay, anyway.
Can't say.
Christian, what if the object covers more than 1.2 degrees?
Since the All-Sky Cam is tracking the object as long as it's visible, these information come to the PTF all the time and correct the interception course on the fly.
Yes, from the fisheye view, no problem. But locally, if the PTF wants to correct itself and the object covers more than 1.2 degrees, what happens with the local correction?
If it's that fast that it, I think it doesn't matter, because we can have around 20 degrees per second as slewing speed.
Okay.
And we can have more if we skip microstepping and go to, let's say, full step. Then we can gain much more speed. So we can keep track of it.
Yeah, true. We can vary.
I think Richard's asking. I think Richard's asking is what if the PTF is lost out of its. So I think it will just have to send a notification to the master control program to say it's lost a target. Can it get updated coordinates if it's?
Yeah.
Yeah, it's still getting updated coordinates from the fisheye.
Just a second. Again, the fusion creates its own projection on the target all the time.
Yeah.
So the fusion is responsible to tell you, hey, I'm not receiving updates, and the accuracy that I have and the projection are getting like more and more like I'm losing confidence in it.
Mm-hmm.
Right?
Yeah.
But it has nothing to do with the fusion. Yeah. With the sensor.
Yes, if the PTF is looking somewhere else, and if the Mikey says something different, then these things are compared and corrected.
Yes.
Yeah. Now my question was just targeted whether if an object is not outside the view, but if it covers the whole view. So let's say if whatever flies around us is a 747, for example. If a 747 flies 500 meters above ground, it covers more than 1.2 degrees. So if a UAP comes very close, let's say 500 meters, would we still be able to locally correct the tracking? That's what I want to say. It's very theoretical and academic, and maybe it's no issue. But how would it
depend on the size? If it's 500 meters right above you and has a size of, let's say, 35 miles, you will have a problem tracking it, because it will stay right above you. You won't see anything else.
And you're tracking something.
I think you'll have a problem in general. I think you'll have a problem in general then, mate.
Bigger problems.
I think trying to figure out if the tracker is the problem is the least of your worries at that point.
Yes.
The fish eye would definitely catch that.
It is more the point that you should go to that station and wait for any contact. They will land there.
So we have to implement this in the software to raise a notification. Please go up and talk to them.
Yes.
They're too close. They're close enough to talk to them. Okay. On this note,
or at least run outside and wave.
Yeah, at least this.
I think if that's the case, then we probably will be on shape already.
Lionel.
Just one more related question. So without, so what's the step size in the micro stepping mode of the slewing of the scope? And without micro stepping, how fast can it move?
The smallest step size I tried with BTTS and with my modifications to the pulleys is 0.2 arc seconds, and this for the normal tracking mode, and the highest speed that I tried out was I reached 11.87 degrees per second with a 10-inch telescope and all the stuff on hand.
So we will be faster.
But since we are not using this accuracy at most of the time, we will be very, very much faster than that.
Yeah.
I think normal speed to be accurate enough to, let's say, have an accuracy of the size of Jupiter, 1.7 arc minutes, we will reach between 20 and 25 degrees per second. So it will be fast enough to track the ISS, of course, and I think faster things than that.
It's a question of stepping. So we can start with your setup, as you said, Christian, and if we find out we need more speed or more accuracy, we go either way. Because
it's dynamically scalable. We just say, okay, we need more speed, then we do not use micro steps down to 0.2 arc seconds. Then we skip the 256 micro steps and go, let's say, for 32. Or if that is not enough, we can scale it up to full step mode, or say 4 steps.
So
it doesn't matter because the motion driver can use it reacts very, very fast to changing the stepping mode.
Yeah. When you go with full step mode, the angles per second, what is the max then?
0.9 degrees.
0.9 degrees? You mean accuracy? No, I'm talking about max
No,
speed.
it's the step size.
Step size.
One step of the motor turns
how many steps per second?
The axis of the motor by 0.9 degrees.
How many steps per second?
400.
Can you multiply for me, please?
400.
Multiply with 0.92. I wanted to know the speed in angle per second.
For one rotation of the motor axis with 0.9 degrees, you need 400 steps.
Which is in seconds, how much?
In seconds, 0.9 multiplied with 3,600.
Is?
Yeah. Take out the calculator.
So I
don't have any on hand yet.
I come about 30 if you divide it. You come about 30, let's say. So 30 degrees per second. That's the max we get out. With the stepping that you set as a preference. If we use a different stepping, gearing, then we have different speeds.
Yeah, if the ratio between the pulleys is different,
yes.
Then it's just multiplication or division of it.
Yeah, true. So what I want to say is we go with a certain setup, which is Christian estimated as a balance between accuracy and speed. But if we in the future face something that we have to be more speedy or more accurate, then we can go either way by changing the gears, right?
Yes, I wrote a configurator about that so that you can just type in that configurator. It is already programmed into BTTTS. You just say what is your gear ratio, and then it calculates the correct values to it.
Oh, cool. Oh, nice. Okay.
Yeah, because if you change something that you say, okay, when I created it, there was a project that was called T-Rex, and it still exists, and it is made for tracking model rockets, and then was sold to NASA to track real rockets. And they're still having a problem because the rockets, the model rockets, are very fast, and they can't pinpoint them in the middle of the image view, of the field of view, and they are still working on the algorithm to get it faster. Mm-hmm. The problem, in my sense, is that they have to change the gear ratio. They are running at full speed, and it is too slow because their setup is too small, and they can't run it faster. It runs with maximum speed, and they can't track, and they can't keep it in the middle of the image. And with the things we are up to, we do not have that speed. So we will be fine with the maximum speed and the dynamic scaling of the microstepping part. If we need more speed, then we can have another gear ratio. Let's say we have a small gear around 10 tooth on the motor, and have let's say a 2-inch pulley on the other side. So we have got a speed up, a gear ratio of 1 to 2.5. So one turn of the small pulley is 2.5 turns on the larger pulley. And this comes in handy because then the speed up is 1.25. Yeah. So if we change only the gear ratio, we can receive the same speed, but we can the top speed gets max.
So what Christian wants to say is, when you shift the gearing, you either gain speed but lose accuracy, or you go the other way. You gain accuracy,
yes,
or
but
lose
you can't achieve
speed.
both at the same time.
You can't have both at the same time. Okay, it's only a shift. So that's why we can in the future see whether we have the sweet spot or we have to shift somewhere.
Can I point out one scenario that I think you'll often need high speed is, like, if you're tracking an object and it goes from the horizon straight above you and then goes behind you, since the tilt mechanism can only go up 90 degrees.
Within the zenith. I think it's around 10 to 15 degrees in the zenith is top speed. But
what I'm saying is, once it goes past you, above you, and then goes behind you, now you need to turn horizontally 180 degrees to continue tracking it.
No, it's a 360 endless panning.
Yes, but I'm saying go vertically. If it goes vertically up and then straight over your head and then behind you, then you're going to need to turn it 180 degrees to continue to go down.
You do not, because you have got a fork mount. You turn it right there, so you can have at any time a full turn declination during that covers the zenith, because you already know that where it's going to, if it's going a straight line.
So what you say is your library is already compensating. Your software is already compensating for that.
Yes.
That swing around. Okay. So
only if you have an equatorial mount, you have to flip the meridian.
Yeah.
The fork mounts don't suffer by that.
All right. I have to quit now, and it's a quarter over the hour, and I would like to ask Santa Claus to say goodbye to us.
Well, this has been yet another It's been yet another exciting development meeting, and I've learned a lot. I hope everybody else has tracking with where their interest is and their things. And we wish you all an awesome season, no matter what your faith, because that's one of those things that seems to get in the act. And to me, it's about the joy of the season. Hey, you survived another year. Okay, the days are still getting a little shorter. They're going to start getting longer.
True.
But it all matters. So, on that happy note, all our viewers all over the world, awesome. And Artemis is currently floating off Baja California just fine. So life is good everywhere.
Bye, Santa.
Bye.
Bye, everyone. Thank you.